Hello children, today we will solve a number of numerical examples so that you will learn how to apply a concept that you have learned till now. तो शुरू करें?
So all the questions that I have chosen today is mainly to explain the constraint relations. So to start with, the first question we have, in this arrangement which is shown here, if speed of point P and Q are u, it is shown this be the speed of the points P and Q. Then what is the velocity of block at given instant of time? As you can see here, velocity of 3 points are related, point P, Q and the point that is in contact with M. So we have to see what will be relation between their velocities. Now if I draw the right hand side, so it can be drawn as, this is block of mass M. Let its velocity be v in upward direction and this angle is theta. Here is velocity of point Q which is equal to u. As you can see that velocity of all the point of string has to be same in the direction of string. So whatever be velocity at this point has to be the velocity at this point in the direction of string. So from here we can write that in this direction speed has to be equal to u, and from here we can write v cos theta is equal to u. So v is equal to u upon cos theta. This is velocity of block M in upward direction because P and Q are being pulled down. So you can see how the velocity of objects can be related if they are connected to each other. In next problem, for this system shown in figure, we have to write constraint equation involving velocity of the blocks. Let us write these pulleys as pulley 1, 2, 3 and 4. Then if I write for pulley 1 and drawing FBD for this, it can be drawn as it is being pulled on both sides in upward direction and then with velocity v1 in downward direction. So if in upward direction is its velocity be vb, then we can write that v1 should be equal to 0 minus vb by 2, which gives vb is equal to minus 2 of v1. Now let me draw FBD for pulley 3. Then as you can see here, which is shown in the diagram, that left hand side is coming down with velocity vb and right side it is moving up with some velocity, let that be vc. Of course, it is being pulled down with velocity v2. Now from here we can write v2 is equal to vb minus vc upon 2. So we got vc because vb already we have derived. So vc can be written as vb minus 2v2. Now I am drawing FBD of pulley 4. On right hand side this is being pulled with velocity v3 and on left hand side the string is coming to it with velocity vc. So from here we can write vc is equal to v3. Now we got the relation. Collectively it can be written as v3 is equal to vb minus 2v2 is equal to minus 2v1 minus 2v2 or 2v1 plus 2v2 plus v3 is equal to 0, which is the desired result. In next illustration, we have to find relation between a1 and a2 and also their values in terms of m1 and m2. Okay, so here we have to calculate, not only write the relation between a1 and a2, but we have to calculate its value as well. Let us start with considering the constraint relation. So from constraint relation we can write a1 is equal to 16 of a2. This you can do very easily if you consider the fixed point as reference and then locate position of all the movable pulleys or blocks and then differentiate. You will get this relation that a1 is equal to 16a2. Now from Newton's second law we can write minus m1g plus t is equal to m1a1 because it is moving in upward direction. So we are writing the equation in upward direction. If we multiply this by 16, we will get minus 16 m1g plus 16t is equal to 16 m1 a1. In place of a1, now we can write a2, 16 a2, so it will be 16 into 16 m1 a2. On solving, we will get minus 16 m1g plus 16t is equal to 256 m1 a2. Let this be our equation number 1. Now let us write Newton's laws of motion for the second block. So then it will give m2g minus 16t is equal to m2 a2. This is our equation number 2. If we add equation 1 and 2, it will come out as, because 16t will get cancelled, so we can write m2g minus 16 m1g is equal to 256 m1 plus m2 and a2 taken common. So we got value of a2, that is equal to m2 minus 16 m1 multiplied with g, and this whole divided by m2 plus 256 m1. If we substitute this value in our first relation, then of course we can write a1 as well, that is equal to 16 times this value. So it will be 16g m2 minus 16 m1 upon m2 plus 256 m1. And we got our answers. In the next illustration, this arrangement is shown. Here mass of body 1 is 4 times that of body 2. Okay, let us consider mass of body 2 to be m, then for 1 it will be 4m. This height given is 20 centimeter. Masses of pulley thread we have not to consider. At a certain moment body 2 is released and the arrangement is set in motion. We have to find the maximum height that body 2 will go up, and this should be in centimeter. Okay, let us start now. First, if we write equation for body 1, it will be 4 mg, because its mass is given 4m. So this is 4 mg minus 2t. As you can see here, body 1 is attached to the pulley which is being pulled by string on both the sides. So the upward tension has to be 2t. 4 mg minus 2t can be written as equal to 4m a1. And for second block, it can be written t minus mg is equal to m a2. One more relation we have between acceleration of a1 and a2 that can be written with the help of constraint relation, and it is equal to a2 should be equal to twice of a1. So if we solve, let us name the equations 1, 2 and 3. If we solve equation 1 and 2, then it will give 2 mg is equal to 4m a1 plus 2m a2. I have simply eliminated t. From here, it can be written a1 is equal to 2 mg upon 8m. While writing this, I have used relation 3 as well, which is equal to g by 4. Similarly, a2 can be written as, this is twice of a1, so it will be 2 into g by 4, that is equal to g by 2. So this is acceleration of block 1 and 2. Now it is asking, find the maximum height the 2 will go. So a2 is moving up with this much of acceleration. Now to calculate height, I am doing this separately here. To calculate height, first we have to consider that the time till the body 1 reaches the floor, both bodies will be moving with these accelerations a1 and a2. But when a strikes the floor, all strings will go slack, and then tension in strings will become 0. When tension has become 0, then force on body 2 will be only force due to gravity. So its acceleration will be only g in downward direction. So then we can write v square is equal to u square plus 2as for the second body. This s has to be equal to 0.4. So it will reduce to v square we can write it will be equal to, u can be taken as 0 because it had started with 0 velocity. When released, then it will be equal to 2. Now value of acceleration of 2, that is equal to a2, which is g upon 2 multiplied with s, that is equal to 0.4. Now from constraint relation itself we can also say that the body 2 will be at height 0.4 meter, which is 40 centimeter from floor A. So this I have taken as 0.4, which is displacement for body 2. If I solve it, this will come out to be 2 meter per second. Velocity we got is 2 meter per second. At this moment, now the body 1 has striken the floor, and after this 2 will be having acceleration, that is equal to acceleration due to gravity. So it has started with this velocity 2 meter per second in upward direction, already has reached a point 0.4 meter, and then it will go some height up so that its velocity becomes 0 at the maximum height. So for that height above the point 40 centimeter, we can write 0 is equal to u square, that is 2 square, which is equal to 4 minus 2gh. G I can take 10 here, and then h. This is height above 40 centimeter. From here we got value of h to be 0.2 meter. So the total height above the ground will be, that is the maximum height above the ground to which body 2 will go, that is equal to 0.2 plus 0.4 is equal to 0.6 meter. Here we have to write the value in centimeter, so it will be equal to 60 centimeter. This is our desired result. One more illustration I have taken to explain the constraint relation. Here mass of ball is 9 by 5 times that of the rod, and length of rod is given 1 meter. Masses of pulley, thread we are not going to consider, no friction is there. The ball is set on the same level as the lower end of rod. As you can see here, they are on the same level. At this moment the ball is released. We have to calculate when this ball will go opposite upper end of the rod. Now here ball and rod both are moving, so it is easier if we write in relative terms. Let us first calculate accelerations of ball and rod. Now with help of constraint relation, we can easily write that if a1 is acceleration of ball, I am indicating here, and rod is having acceleration a2 in downward direction. So we can write easily 2a1 should be equal to a2. This is only in terms of magnitude, not in direction. They are in opposite direction. Now we can write for the ball 2t minus 9 by 5 mg. M I have taken as mass of rod. So for ball it is 9 by 5 mg. 2t minus 9 by 5 mg is equal to 9 by 5 ma1. This is our equation number 1 for the ball. For the rod we can write mg minus t is equal to ma2. Are these two equations clear to you? Let me draw FBD also so that easily you can understand how I have written the equation. For ball, in upward direction force is 2t, in downward it is 9 by 5 mg, and it is moving up with acceleration a1. For rod, upward tension is t, downward force is mg, and it is coming down with acceleration a2. So we got the relations 1 and 2. If we solve these two relations, a1 can be written as g upon 29 in upward direction, and a2 is equal to 2g upon 29 in downward direction. Now we can write acceleration of ball with respect to rod, because with relative to rod it is moving the distance that is equal to 1 meter. So it will be easy to solve if we write in relative terms. Here I am writing acceleration of ball with respect to rod. It has to be equal to a1 plus a2. This is acceleration of ball with respect to rod. Plus sign is here because a1 and a2 are in opposite direction. That will be equal to 3g upon 29. Now we can write for the displacement of ball S can be written as, of course this is relative, so S relative can be written as half into A relative T square. If we substitute value of S relative as 1, A relative already I have calculated, that is 3g/29, then T comes out to be root under 58/30, that is close to 1.4 second. So you can see, to solve this question we have used constraint relation, we have used writing equations from laws of motion as well as kinematical equation. So for a numerical you get in your exams, sometimes 2 or more concepts will be needed to solve the given problem. One more illustration I have now. This is very common also. You must have seen this problem in a number of books. So let us see how it can be solved. First, let us draw FBD for the wedge and the rod. First, I am writing for the rod. What forces are acting on it? It has normal. Do remember that normal has to be perpendicular to the surface of contact, and this is the surface of contact which is the incline. So with vertical also this normal will be having an angle that is equal to, if I take this angle as alpha, it can be written as equal to 37 degree. Other forces is mg in downward direction. No other force, as you can see, is acting on the rod. Now if we apply F is equal to ma to the rod, one more force is there which is not obvious in first sight, but it has to be force due to contact force due to these two constraints which you can see here. So that force also we have to consider. Let that force be, of course it will be in horizontal direction because the constraints are vertical. So let this be F. I have considered the direction towards right. So now we can write F is equal to ma for the rod, that will give F minus n sine alpha is equal to 0. As the rod cannot move in horizontal direction, it is constrained to move only in vertical direction. This is our equation number 1. It can be written as mg minus n cos alpha is equal to ma. This is our equation number 2. Now if we draw FBD for the wedge, what forces are acting on it? Of course its weight will be here. Let that be mg in downward direction. One normal has to be there due to ground, that I am writing by n dash. Other forces will be, of course, this normal which is in direction opposite to what the wedge is exerting on the rod. So this one more n is there. Is there any other force? No, no other force can be seen. And this angle is given alpha. Now if I write F is equal to ma for the wedge, then it is constrained to move only in horizontal direction. So in horizontal direction we have to write net force to be 0. What the forces are there? Now it is constrained to move only in horizontal direction. So in vertical direction we should write net force to be 0. And the forces in vertical direction are n dash minus mg minus n cos alpha. That should be equal to 0. What about horizontal direction? It will be n sine alpha is equal to m into, this time I am writing acceleration as a dash for the wedge. So this is ma dash. Now one more relation we can write between a and a dash, because the rod is constrained to slide along the incline. With relative to wedge, it can slide only in this direction, that is along the incline. So we can draw vector diagram for acceleration. If this be acceleration of rod, this has to be acceleration of rod with respect to wedge, and this is acceleration of wedge. So we can write tan alpha is equal to acceleration of rod upon acceleration of wedge. And what is acceleration of rod? That we had taken as a upon a dashed. So one more relation we got from here. If we substitute these values, finally we can write a is equal to mg tan alpha upon m tan alpha plus capital M cot alpha. the value of acceleration for the rod and for the wedge A dash to be equal to mg upon m tan alpha plus m cot alpha. So now we got acceleration of both the rod and the wedge. Let us solve one example based on the pulley system. A boy and a block, both of same mass, are suspended at the same horizontal level from each end of a light string that moves over a frictionless pulley as shown. The boys start moving upward with an acceleration 2.5 meter per second square relative the rope. If the block is to travel a total distance 10 meter before reaching at the pulley, the time taken by the block in doing so is equal to. To solve this, first we have to write the equation for block and for the mass. So if we consider acceleration of block being equal to A, then we can write for the block, if it is coming in downward direction, we can write mg minus t to be equal to ma. And now for the man, it will be having equation of motion as in upward direction the tension is there, so we have to write t minus mg, and this time acceleration of boy will be equal to acceleration of boy with respect to rope plus acceleration of rope. Acceleration of boy with respect to rope is provided here, that is in upward direction, so let's write this 2.5, and rope of course has to be coming down for the boy, so it will be having value minus a. On solving these two equations, we will get value of a to be equal to 1.25 meter per second square. And so the time taken by block in moving a distance 10 meter will be equal to, we can write 10 is equal to half at square, so 1 by 2 into 1.25 t square. On solving this, we will get t to be equal to 4 seconds, which is our option number 2. One example here I have taken. A light rope is passed over a pulley such that its one end a block is attached and on the other end a boy is climbing up with acceleration g by 2 relative to rope. This is very important. Mass of the block is 30 kg and that of boy is 40 kg. Find tension and acceleration of the rope. Okay, let's start. First, draw FBD for the block on which two forces are there. One is tension in upward direction, other is its weight in downward direction, and it is equal to 30 g. It has mass 30 kg. If it is going up, if we are considering that it is going up, then we can write t minus 30 g is equal to 30a. This is our equation number 1. Here I have considered that block is moving upward, which will be generally the case, because if on the other end you are climbing up the rope, then rope will come down. If block is not very heavy, the rope will come down and block will move up. So I have considered that case, block is moving up with acceleration a. What about this man now? Let us draw FBD for this man also. For this, the weight is 40 g in downward direction. Of course, if the man is pulling the rope with tension T, rope will pull it up with the same tension T. Let us consider that it is moving up with acceleration A dash. Then since the acceleration is in upward direction, so we have to write T minus 40 g is equal to 40 A dash. Now this A dash is acceleration of man. It should be acceleration of man with respect to pulley plus acceleration of pulley. Now this A dash is acceleration of man. So it should be equal to acceleration of man with respect to rope plus acceleration of rope. And what is acceleration of man with respect to rope? That is equal to g by 2 given here. So it is equal to g by 2 plus acceleration of rope. And acceleration of rope has to be same as acceleration of this block, because if this block is moving up with acceleration a, the rope has to come down with the same acceleration a. but it is in downward direction, so we have to put one minus sign here. So now let us solve this. Equation 1 and equation 2. On solving, we will get T to be equal to 300 G by 7 Newton and A will be 3 G by 7. So these are the values of tension and acceleration of the rope. This has to be in downward direction. With this, our today's session is also complete. We will see some more numericals in our coming session. Till then, bye.